In this video, I want to talk about data transformation in regression. For example, we have a nonlinear relationship between x and y, and we want to change it to a linear form by transforming x values. Here we want to apply log x to change the x values and change this relationship to a linear form. In order to do that, first of all, I type the function log and apply it on all x values. Do it for the first cell and then drag it down for the rest. Now I have a new data set of log x. I just denote them by capital X and the original y values. Now I want to apply linear regression here. Actually, I want to find the least square regression line for the capital X and y values. So the rest is same as what you've learned before. So first of all, I have to find the mean of x values. For finding the mean, the total of x values is important to us. I find the total, and the other value which is important is the number of x values. We use the function count of these cells and enter. So ready to calculate the mean of x values. This is the total divided by number of values. So I have the mean of x values. Do the same for the y values. We need the total of y values, total sum. This equals to total divided by number of values. Now for standard deviation of x, I need x minus x bar to the power of 2. Just be careful, we just work with capital X values. This is x, sorry, I have to type the equal sign first. X value minus x bar to the power of 2. And here x bar should be an absolute cell. So I put a dollar before and after L in the address of this cell. Now ready to drag this down and apply it for the rest of the cells. Just come here, drag it down. Now we are ready for finding the standard deviation of x. This is the square root sqrt of this total. I can use this function sum, or just use the auto sum for that. Sum of these values divided by number of values minus 1. Just be careful about the priority of these operations when you type a function or a formula. Okay, now I have the standard deviation of x. Standard deviation of y, the story is exactly the same. Actually, it is the y value minus y bar to the power of 2, and I fix the address of the cell, which includes the mean of y values, to make it an absolute cell. Now I just drag this down and apply it on the rest of the cells. So standard deviation of y equals to s square root sqrt of the summation of these cells, sum of these cells, divided by number of values minus 1. Now I have the standard deviation of y as well. Now for finding the correlation coefficient, I need x minus x bar times y minus y bars, and then find the total of them. This equals to x minus x bar times y minus y bar. Just be careful again, I have to fix the address of the cell, which includes the mean of x value and y value. I put dollars before and after L here as well. Now ready to drag this down and apply it to the rest of the cells. Now this total is important to us. I just click on AutoSum Now it is the total of x minus x bar times y minus y bar divided by n minus 1, which is the number of values here, minus 1 times standard deviation of x times standard deviation of y. Now I have the correlation coefficient negative 0.95. Now for finding the slope, it is r times the standard deviation of y divided by standard deviation of x. Intercept, this is y bar minus bx bar, b times x bar. So the equation of the line is this: y equals to negative 1175.8x, capital X actually, plus a is 2263 point, just round it to 1 decimal points and show it here. So I have this equation. So predicted y values can be calculated by this equation, but at the end I have to change the capital X to log x. So this is y equals to 1175.8 log x plus 2263.3, right? So I have the function here. I can just change the width of that a little bit to have the whole here, or just use the wrap text. So it is the function here that we can use, is the equation that we can use in order to find the predicted y values when x value is given. Just here I type the b log x first and the a at the second to show you it doesn't matter which one is first and which one is second, because we have addition here.